To understand human fatigue, we have to discard the idea that it simply means feeling tired. Clinically, fatigue is a biological drive for recuperative rest that results in a severe, quantifiable state of reduced cognitive capability and neural misfiring. Scientific research provides a precise equivalency metric for this cognitive degradation. Staying awake for 17 to 19 hours produces the exact same motor and cognitive impairments as a blood alcohol concentration of 0.05%. If an operator pushes that wakefulness to a full 24 hours, the impairment escalates to a BAC equivalent of 0.10%. At this level, reaction times slow by up to 50%, working memory breaks down, and judgment is compromised well beyond the legal driving limits of most jurisdictions. The most dangerous aspect of this state is the psychological blind spot it creates. Sleep-deprived individuals lose the biological capacity to accurately assess their own degree of impairment. Relying on an operator's subjective feeling of alertness is a systemic vulnerability. When a brain cannot evaluate its own failure, catastrophic errors become inevitable. In heavy industrial transport, operations run continuously. Historically, these industries managed human limits using prescriptive hours of service logs, essentially tracking time on a clock. These static rules fail because they treat human beings like mechanical assets with predictable duty cycles. They ignore the underlying neurobiology of how the brain actually processes sustained wakefulness. Regulatory bodies are actively rewriting this standard. Under modern frameworks like Western Australia's Work Health and Safety Act 2020, fatigue is legally classified as a primary psychosocial hazard. The legal duty of care now requires the person conducting a business or undertaking to actively eliminate or minimize these physiological risks. This requires moving past simple compliance audits and utilizing data to model and predict cognitive impairment. Industrial safety must evolve from counting the hours a worker has been on the clock to mathematically predicting the biological degradation of their brain. This Cartesian plane plots the two-process model, the mathematical architecture proposed in 1982 dictating human consciousness. The first mechanism is process S. During a normal daytime schedule, process C provides a rhythmic drive for wakefulness. This internal clock pushes back against the mounting pressure of process S, maintaining stable alertness. When an operator works a night shift, they force wakefulness when their biological clock is programmed for rest. The two processes violently desynchronize. The circadian rhythm now compounds the homeostatic sleep pressure rather than opposing it. Industrial fatigue is not a failure of operator willpower. It is the unavoidable mathematical divergence of these two biological equations. The consequences of this biological desynchronization are particularly severe in nocturnal aviation and continuous transport operations. Looking closer at this highlighted section of the graph from 2 a.m. to 6 a.m., we isolate the window of circadian low, or WOCL. This is the biological nadir where the wakefulness drive bottoms out while sleep pressure reaches its maximum peak. During these 4 hours, the brain's performance relies entirely on an exhausted homeostatic system. Operators experience profound lapses in attention, slowed reaction times, and degraded situational awareness. Abruptly awakening an operator for a critical task triggers a secondary hazard, sleep inertia. This is a transitional state of severe grogginess and disoriented cognition. While basic arousal centers in the brainstem reboot within 5 minutes of waking, the prefrontal cortex, responsible for complex decision-making, takes up to 30 minutes to fully reactivate. If an operator is awakened from deep slow-wave sleep during the window of circadian low, the severity and duration of this inertia are exponentially magnified. Demanding immediate executive function or complex decision-making from a brain trapped in sleep inertia is a neurobiological impossibility. Beyond the internal clock, external factors in heavy, earth-moving operations place a compounding physical toll on the human body. These extreme environments trigger the arousal paradox, a dangerous illusion where an exhausted worker subjectively feels highly alert. In high-stakes situations, the brain's reticular activating system releases adrenaline. This neurochemical surge effectively vetoes the homeostatic drive for sleep, forcing the cortex to stay active. This masking is visible in neural activity. The limbic system and brainstem run highly stimulated, but the prefrontal cortex remains metabolically sluggish and profoundly impaired. Because the prefrontal cortex is compromised, the operator loses their executive function. They retain basic motor skills, but lose impulse control and the ability to accurately assess risk. Severe environmental conditions amplify this breakdown. In extreme heat regions like the Pilbara, the body expends massive amounts of energy just to cool itself. Safety systems measure this capacity using the thermal work limit, the mathematical threshold defining a human body's maximum ability to dissipate heat. When an operator breaches the thermal work limit, physiological strain accelerates the onset of both physical lethargy and total cognitive collapse. Add to this the constant exposure to industrial noise above 75 decibels. This acts as a secondary biological veto, forcing the brain into distraction and destroying working memory. An operator who feels awake in an extreme environment is experiencing a biological lie, one that masks imminent catastrophic failure. The logistics of remote workforce deployment, specifically fly-in, fly-out operations, introduce an entirely separate class of risk. The structure of remote work inherently induces travel fatigue, chronic schedule disruption, and prolonged isolation from social support networks. This bar chart displays data from a 2026 survey showing 75% of FIFO workers reporting their current rosters as unsustainable. The data specifically isolates the 68% of the workforce trapped on long swings, rotations of 2 to 3 straight weeks on site. These extended rotations prevent adequate recovery, leading to cumulative fatigue. A microscopic daily sleep debt compounds exponentially over the course of a multi-week swing. The risk profile spikes drastically on the fly-in day. Waking at 3 a.m. for a flight, followed immediately by a 12-hour shift, pushes an operator directly into the 17-hour intoxication equivalent on the very first day of their rotation. On site, psychosocial masking takes hold. Workers routinely suppress fatigue reports due to job insecurity, contractor vulnerability, and a culture that normalizes exhaustion. Treating humans with the limitless duty cycles designed for mechanical assets inevitably breaks both the individual and the safety infrastructure meant to protect them. To counter this, heavy industries are implementing fatigue risk management systems, creating tightly engineered controls around human limits. These systems integrate wearable biometrics that track heart rate variability and core body temperature in real time. Biomathematical AI platforms, like the SAFED model, ingest this physiological data to accurately predict cognitive impairment hours before a microsleep actually occurs. Organizations are also engineering the visual environment itself through the science of photobiology. This chart illustrates the eye's action spectrum. Blue light at 460 nanometers hits retinal receptors, forcefully suppressing melatonin to zero, driving alertness. During night shifts, workplaces utilize warm, blue-depleted lighting. Keeping wavelengths above 630 nanometers preserves melatonin secretion, protecting the biological clock. Industrial safety is no longer about enforcing static rules on a timesheet. It requires mathematically predicting, respecting, and actively protecting the unyielding limits of human neurobiology.